In this series, we're going to look at voltage drop testing the starter motor circuit. We start by cranking and noting the source voltage to the starter motor. We want to make sure it's ample to meet the starter's needs. Next, we're going to measure the voltage drop of the insulated circuit, so from battery positive to the cable wire going into the starter motor. We note the voltage while cranking. Maximum volt drop is 1/2 of a volt while cranking. Followed by the ground circuit test. In this case, we will go from the starter motor frame to the battery negative. Note the voltage while cranking. On the ground side, we're looking for 3/10 of a volt maximum volt drop, since it does not have as many components as the insulated circuit. If the starter motor circuit passed both the insulated and ground circuit tests, you're done. If it failed either, you must continue and break the system down into individual pieces. We'll start by measuring the positive battery cable. So going from the positive battery terminal to the B positive terminal of the solenoid. We'll note the voltage while cranking. Maximum volt drop is 1/10 of a volt for each cable and each connection. The two larger terminals shown on the solenoid, the top one is the B positive terminal of the solenoid, the bottom is the M terminal of the solenoid. Here we're voltage dropping the terminal connection, so the red lead is attached to the battery cable and the black lead is attached to the B positive terminal of the solenoid. We'll crank the circuit. Maximum voltage drop is 1/10 of a volt. Next, we'll do a voltage drop of the solenoid itself, from the solenoid's B positive terminal to the solenoid M terminal. During cranking, the maximum voltage drop is 3/10 of a volt. Our next step, we are going to measure the voltage drop from the solenoid's M terminal to the wire going into the starter motor itself. Again, this is a single connection, so the maximum voltage drop will be 1/10 of a volt while cranking. Here we have the red meter lead on the starter motor's input wire and the black meter lead on the starter motor frame. When we crank the starter motor, we are seeing the available voltage to the starter motor itself. Our mock-up's a little different than the actual automobile. As you can see here, our starter motor bolts to a 90-degree L bracket, and the battery cable bolts almost directly onto the starter motor itself. In the automobile, starter motor is going to bolt to the engine block, and then the battery cable is going to bolt to the engine block somewhere else. There will be a voltage drop there as well. So a test that's omitted from this series would be going from the starter motor's ground to the battery negative cable. Maximum voltage drop there would be 1/10, as it is a single connection. Our final test will be from the battery negative cable, where it attaches to the engine block, to the negative battery terminal. During cranking, the maximum voltage drop is 1/10 of a volt for this connection. Before finishing, don't overlook the battery terminal connections. So from the battery terminal to the battery post, during cranking you should have 1/10 of a volt. You'll do this for both the positive terminal and the negative terminal. Anywhere in this sequence, if your voltage drop exceeds the maximum allowable voltage drop of 1/10 of a volt per connection, or 1/10 of a volt for a cable, the first step would be to clean the cable or connection, and if you can't get the voltage drop under 1/10 of a volt, you would replace the cable or connection.